in my space, behind me. Torsional strain, you're behind me. Steric strain, you're spinning in my space. They call it steric hindrance when you are really in my space. Let's take a look at the cycloalkanes, only because you're going to name. So I want to introduce them only because you're going to name. All right, so here they are, don't copy. Here they are, don't copy. You don't want to do that. What we're going to do is make sure that you know how to name. All right, so that way you can do a lot of work. We want you to do a lot of work this weekend. A lot of work. You're going camping. People are going, I'm going camping. I don't even have a computer. All right, so my cycloalkanes. Take your papers with you. Cycloalkanes would have that general formula. I'll start with my little triangle. My little triangle. I'm going to put like little teepee on it. I'm thinking camping. My idea of camping now is that, you know, a wonderful suite at the Hilton. All right, so what will we call this? No longer sleeping in a teepee, too old. What are we going to call this guy? 1, 1, dimethyl cyclopropane. Okay, we want to start out like that. 1, 1 dimethyl cyclopropane. I'm going to skip the square because I do such a horrible job. And we start with stereochemistry. And when I'm going to go ahead and do these guys like so, these guys like so, this is saying they're both pointing in the same direction. Same direction. Same side cis. That terminology, same side cis, is the beginning of what we call stereochemistry. I'm going to put here a bromo, and I'm going to put here a chloro, and how are we going to name then this compound? You are going to start with the word cis dash, 1 bromo, 2 chloro, cyclopentane, very good. When you come back on Wednesday, bring colored pencils, please. We'll be drawing. Well, bring 2 different colors at least. Red and green will be great. Okay, red and green. It's like Christmas. We're planning already. Yay. All right, let's draw another one. I love fall. I love the fall season. Oh, heavens. Then we can do some wild things like this. Because we go crazy rápido. And then we'll do, and then we'll come over here. All right, we're running out of time, so I won't make this crazy. All right, so already where are the groups going? Can you see that the groups are going opposite? Groups are going opposite. One is coming to the front, the other one is going to the back. When you have one to the front, the other one to the back, this is called trans. One to the front, the other one to the back, they're called trans.
I'm a little confused because you can see this in like 3 dimensions. You can see it from like side to side, or you can see it front to back. So when it comes to cis and trans, like if the bromide and the chloride were like, one was coming forward with the black triangle and one was coming backwards with the dashed lines, then would it still be called cis if it's on that side?
The only way that it will be called cis, and your argument is great, if they were both in the dashes, then they would still be called cis. So you can see them from the front. I mean, like if your argument is great, I'll explain her argument better, even though I was dinged once because somebody in a big theater asked me a question and I replied without answering what she said. She's saying, what she's saying is that what happens if you're looking at this from another direction, right? If the molecule is pointing like this, and you're over here, of course, they're coming to the front, but the person that is in the other room is I'm going that way, right? The person in the other room sees those two going the other way. It's still cis. Cis means they're pointing in the same direction, either both to the front or both to the back.
And if they were switched.
If they're switched, then it's trans.
Because I'm looking at it as like on the right-hand side as well.
Because they're right next to each other.
Yeah, they're right next to each other and everything, but if you just put the bromide on the other side and then they were across from each other, even though they're still facing back, would they still?
Let me make your life very simple for you,
Okay.
okay? Don't look at it from everywhere. If they're both wedges or they're both dashes, that represents they're going in the same side, okay? So that's the, what is the word that I'm looking for? You know, that's the, huh? Yeah, but this is the way that we look at a type of carbon that has three-dimensional, right? So a three-dimensional carbon, you're gonna have your solid lines, and then the representation of what is the orientation of them. So if they show them both on wedges or both on dashes, the agreement is that that is called a cis isomer. If they're on opposite orientation, if they're to the front and to the back, or to the back and to the front, they're opposite, then that is called trans. Okay? And we'll have another layer in chapter 5, by the way. So there's yet another layer. Maybe in chapter 5 that will be even more helpful to you. We don't want to leave without finishing the name of this. This will be called what?
Trans, 1-ethyl, 3-methyl.
3-methyl cyclopentate. Okay, expect then emails from me, because I don't know if everybody knows what I want you to do, so, or the story that you didn't hear it. Alrighty.